You are standing in your kitchen. Maybe the coffee is brewing. Maybe the light through the window is doing that thing it does in the morning, spreading across the countertop like it has all the time in the world. And you do something you've done 1,000 times. You look out at the sky. Maybe you see a cloud, maybe a plane, maybe nothing at all. And you think without thinking that you are looking out, that you are a small thing in a very large space, that the universe stretches away from you in every direction, vast and indifferent and impossibly, almost insultingly large. That's the belief. You, small, universe, enormous. The universe is out there and you are in here, and between you and all of it is a distance so unthinkably large that your mind can't actually hold it. It just surrenders to the word billions and moves on. But here's the question I want you to sit with before we go any further. What if the entire observable universe, every galaxy, every quasar, every photon that has ever reached a human eye from the furthest edge of what we can possibly see, fits right now in a space smaller than a single proton was in the first fraction of a second after the Big Bang? What if the size of things isn't a fixed fact about reality, but a relationship, a ratio, that depends entirely on when you're doing the measuring? What does big even mean? Let me tell you something. I spent a long time, probably too long, thinking about size the way most people think about size. You have a ruler. You put one end at the start of the thing and read the number at the other end. Simple, clean. The universe is 93 billion light years across. Done. Next question. But then I started looking more carefully at what that number actually means and where it comes from. And I realized that the universe doesn't hand you its size the way you hand someone your height. The universe hands you something much stranger. It hands you light. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. Let's find things out together. Now, light. We have to start here. Light leaves a star and it travels. It travels at 186,000 miles per second, which is the fastest anything in this universe is allowed to go. And not just as a practical limit, not just because we haven't built a fast enough engine, but as a deep constitutional fact about the structure of space-time itself. Light goes fast, magnificently fast. And yet the universe is so large that even at that speed, the light we're seeing from distant galaxies left those galaxies not years ago, not centuries ago, but billions of years ago. When we look at the most distant objects we can observe, we are not seeing them as they are. We are seeing them as they were. 13 billion years ago, when the universe was young, when those galaxies were burning bright before most of their stars had even formed. Do you see what happens? Your eye is a time machine. Every time you look at the night sky, you are looking at the past. The further away the object, the further back in time you are looking. The universe, it turns out, doesn't show you its present. It shows you its history. Stay with me because this is where it gets interesting. There is a distance, a specific calculable distance beyond which no light will ever reach us. Not because there's a wall, not because something is blocking it, but because the universe is expanding, and beyond a certain point, the space between us and a distant galaxy is growing faster than light can cross it. That boundary, the edge of the observable universe, is roughly 46 billion light years away in every direction. Everything inside that sphere is, in principle, detectable. Everything outside it is forever beyond our reach. Not unknown, unknowable. That sphere, 93 billion light years across, containing something in the range of 2 trillion galaxies, each galaxy containing hundreds of billions of stars. That is the observable universe. That is the thing on your thumbnail. Now here's the part I want to spend some time on because it's where people's intuitions go wrong in a very specific and interesting way. When you hear 93 billion light years, your brain does something understandable but incorrect. It pictures a fixed container, a cosmic box, a sphere of a fixed, enormous size, and you somewhere near the middle of it, very small. But size, I have to tell you, is not an absolute. Size is a ratio. And the ratio depends on what you're comparing. Think about a photograph. You take a picture of a mountain, and that mountain, which is 3 miles high, fits on a rectangle the size of your palm. Is the mountain small? No. Is the photograph accurate? Yes. The image is a compressed representation. The information about the mountain is all there, encoded in a few square inches. Now, at what point does the mountain become the photograph? What moment in the compression is the moment the thing changes its nature? This is not just a metaphor, this is physics. In the first fraction of a second after the Big Bang, at around 10 to the negative 35 seconds, which is a number so small that even my enthusiasm for small numbers runs out, the entire region of space that would eventually become our observable universe was compressed into a volume far smaller than a single proton. All of it. Every particle that would eventually become every galaxy you can see in every direction tonight was packed into something you could not see, something that would pass through the eye of a needle without touching the sides. And then, for reasons we are still honestly working out, that region expanded, inflated in a burst of exponential growth from something subatomic to something macroscopic in a time so short that we don't have a word for it that fits naturally in conversation. Let's be honest about something here. When I say the universe expanded, I do not mean the matter in the universe flew outward into empty space like an explosion. I mean space itself expanded. The fabric, the medium, the thing that distances are measured in grew. Every point in space moved away from every other point, not because things were moving through space, but because space itself was stretching. The galaxies are not running away from us. The space between us and them is growing. This is the analogy I want you to hold. Imagine you take a rubber band and draw two dots on it. Now stretch the rubber band. The dots move apart. Did either dot move? No, the rubber moved. That is, with all the limitations of every analogy, the closest I can bring you to what cosmic expansion actually means. Now I want to take this deeper. If space stretches, then the distance between 2 points is not a fixed fact. It is a fact that changes with time. What was once subatomic is now 93 billion light years across. The same stuff, the same information, just stretched. So when your thumbnail shows a picture of the observable universe, when some clever graphic shows all 2 trillion galaxies in a circle on your screen, it is not lying to you. It is showing you a compression, an accurate compression. The information is all there, represented in a rectangle a few inches across, exactly as it was all there in a volume smaller than an atom, 13.8 billion years ago. Size, you see, is not in the thing. Size is in the relationship between the thing and the ruler you're using to measure it. And we are using light as our ruler, and light has been traveling for 13.8 billion years, and the ruler has been stretching the whole time it was measuring. This is the part that keeps me up at night. If you take this seriously, and I think you should, then you have to ask the next question. And the next question is not comfortable. If the observable universe is defined by the distance light can travel in the age of the universe, then the observable universe is not the universe. It is our universe. It is the bubble of reality we have access to, the slice of what exists that we can, even in principle, know about. Outside that bubble, the universe continues. We have no idea how far. It may be infinite. And if it is infinite, then our observable universe, these 2 trillion galaxies, this 93 billion light-year wide sphere of everything we will ever know, is, in an infinite universe, exactly as large as a single point. Infinite space doesn't have a center. Every point is the center of its own observable universe. You right now in your kitchen with the coffee and the morning light are standing at the center of a sphere of knowable reality that no one else in the universe shares with you. There are regions of the universe so far away that, even accounting for the finite speed of light and the age of everything, they will never be in causal contact with us. They cannot affect us. We cannot affect them. They might as well be a different universe, and in some meaningful physical sense they are. Do you see what happens? The universe is not one thing with one size. It is an uncountable number of overlapping spheres, each centered on an observer, each containing different information, each real, each complete from the inside, each invisible to all the others. Now here is the uncomfortable implication, and I want to state it plainly without softening it because it deserves to be stated plainly. There is no view from outside. There is no perspective from which the whole universe can be observed. Not because we lack the technology, not because we haven't built a big enough telescope, but because observation is always local. Physics is always done from a position. Every fact you have ever learned about the cosmos was learned from inside a bubble, using light that traveled to you from inside that same bubble. interpreted by a brain that is also inside that bubble. We have never seen the universe. We have seen our neighborhood of it, lit up in the light of our past, and called it everything. And now the visceral thing, the part that connects this to your body right now as you watch this. The light arriving at your retina this moment from the furthest stars you can see left those stars before the earth existed. Your eye is receiving information from a time before you, before your parents, before the entire evolutionary line that produced you, before the sun. You are, at this moment, a receiver for signals from the ancient universe. The photons hitting your eye have been traveling since before the planet you're standing on had cooled. You are not separate from the cosmos, looking at it from outside. You are an event inside it, registering a small corner of its history, calling that corner reality. And here is why this is not terrifying but profound. The fact that the observable universe fits on a thumbnail, the fact that we can compress 93 billion light years into an image a child can hold, is not a sign that we have diminished the universe. It is a sign of what compression means. A photograph of a mountain is not less than the mountain. It is the mountain encoded. And you, looking at that thumbnail, are the universe encoded. 13.8 billion years of expansion and cooling and gravity and light compressed into a creature with eyes trying to understand what it's seeing. The universe is not too big to be known. It is exactly big enough to have produced something capable of knowing. Every fact we have is a compression. Every image is a ratio. Every measurement depends on a ruler that is itself part of what is being measured. And yet here we are, getting it mostly right, building models that let us predict what happened in the first microsecond of time and what will happen in the last trillion years, using nothing but light and mathematics and the willingness to sit with uncomfortable answers. The universe fits on your thumbnail because the universe in the end fits inside the mind that looks at it. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.